Okay, class, is this audible? Yes, walaikum assalam, sir. Okay. It's a different number that has been added. All right. I'll just capture this now. Fine. Sir. Abia? Is Abia here? No, yes. Rest of you are added now on the group. Wafia, you are also there?
Yes, sir.
All right. All right. Now see, in the last class, I had shown you the direction, how to do the direction. Magnetic field, Biot-Savart's law we had done, that was mu naught I dl sine theta divided by 4 pi r square. One right hand thumb rule that we followed was to place our fingers in the direction of current and curl the fingers towards the magnetic field where we have to calculate. That curvature will give us the magnetic field. Now the next other method is just keep your fingers in the direction of current, all the four fingers in the direction of current, and then curl your fingers towards the point. For example, just do it along with me right now. If you keep all your fingers in this position, I, and keep it in such a way that you are able to curl your fingers towards a point. Where is your thumb leading to? Tell me in the chat box right now. Where is the thumb leading to? Keep your fingers in the direction of current, all your hand in the direction of current. And then curl the fingers towards a point. See where your thumb is leading. Upwards, downwards, outwards, inwards, where? Only Fahad got the answer. Others also try. How will you understand them? This method is very helpful. You know, whenever I have to, if I have to solve a question, I use this only second method. It's better than that curvature thing. Curvature thing can be confusing. So I think upwards, downwards. See, how did you keep your fingers? Fingers should be in the direction of the current. Curl your fingers towards a. Thumb is where? Away from the page means is the thumb pointing towards you or is the thumb pointing towards the page? First tell me this. Someone asked something. No, after keeping fingers in the direction of current, should we move the thumb? No, you don't need to move the thumb. All the four fingers, no. Index finger, middle finger, ring finger, little finger. All these four fingers in the direction of current. And then curl them towards a point. Thumb will be where? Thumb will be in its original position. That will give you direction. Only Fahad has, I think, done it correctly. Others also. Any modifications in your answer? The fingers are pointing outwards. Fingers or thumb, Samya? Fingers are pointing outwards or thumb is pointing outwards? Thumb is outwards, no? Madhya, right. Fahad is right, Madhya. Samya? Get the clarification done first. See, you are confused. Okay, okay. I'll help you. Just give me a second. This camera is not working. Let me just fix it. Is it is the camera? Are you able to see the camera? Again, it's just a second. Just a second. I think it has started now. Now, see, I was saying keep the fingers in the direction of current. See, how will you keep it? Current is this. Current is moving upwards. This is the direction of current, flow of current. So how will you how you have to keep your fingers? Your point A is over here. This is the direction of flow of current. So like this, if you will keep, like this you can keep, like this you can keep, or like this you can keep. These are the only possible ways to keep your four fingers in the direction of current. First four fingers. So if I keep the fingers in this way, this is the direction of current, so this is the hand. And I am curling it towards point A. Thumb is where? Thumb is pointing towards me. Did you get it? Why is it outwards? Understood by all of you or not? Any confusion, any doubt? Understood. All right. Now tell me for this A. Using this rule only, not the last rule that you studied. Only this rule. Apart from Madiha, Madiha has given the correct answer. The others also try. Keep your all the fingers in the direction of flow of current and curl your fingers towards a point. Like if this was the current, I curled it towards a point. Thumb gave me the direction of magnetic field. Like this. Do it for this A part. Example 2. For this A, Fahad, Sahal, Wafia, Samia, who all are there? Rifat, try. Otherwise, you won't. This will keep on troubling you. Direction is very important. How would we keep the hand for B? Sahal, for A first tell me, no. A, it's incorrect. C, I'll tell you what. This is now the direction of flow of current. It's pointing downwards. So I have to keep my hand either like this or like this or like this or like this. That's the only possible way. Downwards it has to point out. So if I keep my hand like this and I curl it, thumb is leading into the page. Is it clear? If I keep it like this, I'm not able to curl it towards a point. If I keep it like this, downwards, and then I curl it towards C, like this. This is the hands. This is the direction of current that is going. Curling towards a point, thumb is leading into the page, inwards. So it will be inwards. Now clear to all of you. Two parts we have done. Tell me for this one. Try it for this one. Sahal is right. Others? Fahad, right? Sahal, can you do one thing? From your dad's phone, can you just send this number, whatever you've written in the chat box, no, to me? Just please send it. Is it possible for you? Thumb. Yes, yes, right. Fahad, right. Sahal, just let me know. With that phone number, like, is your dad's phone available to you? Is if he is with you, then will you be able to send the number on the group? Then we can re-add you. Just let me know, Sahal. See for B part. This is the direction of flow of current. Current is pointing upwards. This is the direction of flow of current. B point is now situated here. Curling it, and then thumb is leading inwards. In the group, because Learnivio, the whole team and the management staffs are there only, not the group. So they'll directly see your number and they'll add you. Or I can also add you. So just send it on the group, that will be better. If it's possible for you, that's what I was asking. Alright. Clear this one, class. This is the direction of flow of current. Curl your fingers towards the point. Thumb is leading into the page. Similarly, for this one, this last one. This is the direction of flow of current. Curl your fingers. Thumb is leading outwards for this point. So again, last time I'm repeating. For A point, example 1, this one. This is the direction of flow of current. Curling towards A point, it's leading outwards. This was the symbol, no, of outwards. Dot. B point, curl, thumb is leading inwards. Then example 2, A point, like this you have to keep, curl your fingers, thumb is pointing inwards. Direction of the point, direction of magnetic field. We are finding the direction of magnetic field. Magnitude you can find out using Biot-Savart's law. This is giving us the direction of magnetic field. This was inwards. This becomes inwards and this becomes outwards like this. Fine. So just note down this direction thing and then do a question on Biot-Savart's law. Direct question. First note down the law.
Ma'am, like if it comes in exam, we have to write all the methods and do it.
No. Never, never. You don't have to write the whole law or something. Questions will be like I'll show you. For example, this is the question given to you. You will be doing it. So magnitude you can easily calculate using Biot-Savart's law. And then for the direction, you just have to apply it. Method 1, method 2, whatever suits you. Just apply it. Like this is the current carrying conductor. This is point P right now. So I'll place my fingers in the direction of current. I'll curl it towards this P point. I'll see where the thumb is leading. Let's say, for example, thumb is leading towards, randomly, let's say it's leading towards positive x-axis. So I'll write the magnitude. Let's say magnetic field came out to be 10 Tesla. So I'll write my answer as 10 Tesla I cap or 10 I cap Tesla, like this. Or it can be given to you to just specifically like this, tell the magnetic field direction, inwards, outwards, which unit vector, like that. You never have to write down the methods. Methods are just for your knowledge. By chance, if you forget what was the method. Did you try this question or not? Any answers by anyone? Or should we discuss it? See, position vector, this was the current element, no? Positioned on x-axis. At y-axis, at this was the P point given. Everything was mentioned to you. R was given, DL was given, current is given. Using simple Biot-Savart's law, you have to calculate. Let's discuss it then. See, Biot-Savart's law is what? Angle between the position vector and the current element is 90 degree. So So mu naught by 4 pi. So mu naught by, this becomes mu naught by 4 pi IDL sine 90 degree divided by R square. So B is, mu naught is what? Mu naught is 4 pi into 10 to the power minus 7. Or mu naught by 4 pi, you can write it as 10 to the power minus 7. Mu naught by 4 is 10 to the power minus 7. Current is what? 10. DL is 10 to the power minus 3. 4, this was already written as C, mu naught by 4 pi is 10 to the power minus 7. Above also it was written. So R square means 10 square. So what are we left with? 10 to the power minus 7 or 10 to the power minus 6 into 10 to the power minus 3 into 10 to the power minus 2. That becomes 10 to the power minus 11. Now see the direction. How to write the direction? Direction is very simple. This is the DL, the current element. This is the position. How to keep it? Point P is located there. Curl your fingers towards point P. This was DL. Curl your fingers towards point P. Thumb gives you direction of magnetic field. Understood? This is the direction of current now. Now, if you curl it towards P point, thumb is leading outwards. Outwards is what? Outwards is your K cap. How inwards, Fahad? It will be outwards, K cap. See, I'm showing you. This is the direction of current. P point is located somewhere here. Curl your fingers. Father, you're using your right hand, no? Thumb is outwards. That is your K cap. But tell me, is it clear? Why will it be K cap? To others also, is it clear? Alright. So this way we have to write it K cap Tesla. That's how your magnet, this both the things will get utilized. Magnitude also and direction as well. Just note it. Then we'll do certain derivations, and those derivations are very important, very important. When will the direction be J cap? See, J cap can be, for example, your current element is moving like this. See, right now P point was not located like this in front of it. P point was located above it. It can happen. This is your current element flowing. The point is located here, like this. Point is located here. Then when you curl your fingers, upward the thumb will go. It can be J cap. Clear, Madhya? So it can be anything. 10 to the power 3. Where 10 to the power 3? This 10 to the power minus 3, Fahad. Are you asking this? See, DL we write, no? So DL is given what? The current element is already given to you as 0.001. So that can be written as 10 to the power minus 3. You can write this as 1 by 1000, no? So this one. You can write outwards or inwards as well, but when you say k cap means already you're writing outwards. So you can even write outwards. That will also be fine. Since here axes were given, so that's why it was better to write k cap to especially signify that this is outwards is showing as positive z axis. Outwards, inwards you can write that. That will also go. And class. Now, using this Biot service law, now we have no certain applications. This you have to know what is the outline of it. Application of Biot law is very important. You know, when you're in your exam or if your syllabus is given like magnetic field, so Biot law by default gets included along with the application of Biot Applications of Biot law will be used not only for your board exam, for your entrance exam, JNEET, and every exam, and different systems will be given to you. You will learn every system individually. It can happen in the exam that systems get mixed up and they will be given to you. For example, magnetic field due to straight wire we will do. It can be finite, it can be infinite wire. Now, this finite wire is now not included in your syllabus. Also, the derivation of this has been deleted. So we'll just learn the formula because formula is included. We'll do the formula. Circular wire, everything you have to remember. For a circle at the center of a circle, it is possible at the axis of the circle that we'll see. Axis, obviously, it won't be done in today's class, but magnetic field due to infinitely long wires. See what is meant by this. Magnetic field due to infinitely long wire. This is a wire, current I is flowing. This is extending from plus infinity to minus infinity, means this wire is completely extending to infinity. There's a point P that I have chosen. This is the separation. Let's say A is the separation. Can anyone tell me what is the position vector that I have used? What is the symbol of position vector that I have used here? See the figure. What's the position vector? A, exactly, Wafia. Others also. See, this was the position vector, no separation of point from the current element. Now, magnetic field will be mu naught I divided by 2 pi, where I is what? I is the current flowing, A is the position vector. Fine, this is the formula that you have to remember. So now your work has become easy. Otherwise, this derivation was very lengthy. The only derivation that students used to hate was this only, long wires. So this is not now included in your syllabus. No need to go into the details. Now, Second case, if your wire is semi-infinite, no derivation for first case. But Fahad, do not ignore the formula. All right, questions will be there from the formula. No need of the derivation. Derivation, I think you just have for the circular coil. This you have to remember the formula. Other derivations are there in this lesson. Derivations are there. For circular wire, you have to remember. Finite wire was also deleted. Finite wire was also a lengthy process to calculate sine theta 1 plus sine theta 2 used to get involved. But now your work is easier. So please try to remember all these things. So semi-infinite means one end is at infinity, other end is fixed. And in case of semi-infinite wire, the point is lying towards the finite end. One end is finite. See, this end is infinite. This is the finite end. And point lies where? Point lies near the finite end. This is again A. Magnetic field's formula is mu naught I divided by 4 pi A. This is a case of a semi-infinite wire and point lies near finite end. Now, before you note down all these things, one thing that I want you people to tell me. Looking at both of these, this formula as well as this formula, can you tell me what should be the nature of graph if I plot between B and A? Look at both these formula, this one and this one. What kind of graph? Straight line, hyperbola, parabola. They are directly proportional, so straight line. What do you people say? No idea to anyone? Yes? Madiha? How are magnetic field and A related? Look at the formula and answer. Do you see they are directly proportional to each other? How do you think they are related?
Inversely proportional.
They are inversely proportional. So the graph will be also of inverse proportionality. B and A, this will be simply like this. Just in case a graph comes, keep in mind to write this. Because why? You have a cylindrical wire case especially. There the graph becomes important. So that's why you need to differentiate between all the graphs. Note down these points, then we'll do questions on this. See, here 3 points are given to you. A point is there, here the wire is infinite. C point is there, here wire becomes a semi-infinite for you. And B point is located on the axis. Don't worry about the B point. B point answers can be wrong, but at least A and C, both of it you can answer based on direct formula. Yes, I'll scroll up. So again, when you're doing A part, forget other points that I mentioned. Just consider it as an infinitely long wire. When you're doing C part, forget other points. A as if A and other points are located. Just solve it as if it's a semi-infinite wire. And B part, it is located here on the axis. Try at least submit your answers based on formula, then we'll discuss it in 2 to 3 minutes. Sahal, that was at point A. Fahad, the answer that you're telling me, is it for which point? Mention the points. A, B, C. 3 parts are there. So mention it. So class lasts 2 minutes, then we'll discuss it. Okay, point C you were telling, Fahad. Fine. See, for A point, if A is an infinitely long wire, magnetic field at A will be what? Mu naught I divided by 2 pi A. Rifat, can you tell me what is A in this first part, A part? What is the value of the small a, Rifat? Can you try, Rifat, once? Yes, Fahad, right. That's 2. See, Rifat, this distance is 2. Clear, Rifat? So, mu naught's value is what? Mu naught's value, this is 4 pi into 10 to the power minus 7. Current is 10 amperes. This is 2 pi into 2. This gets cancelled. 2 also gets cancelled. 10 to the power minus 6. Now, nobody has mentioned the direction. Neither Fahad nor Sal. Direction you people have to mention. This is what we have done. We have already done. Place your fingers in the direction of current. If you curl your fingers towards A point, where is the thumb pointing? Answer, class. Reply in the chat box for this part. Yes, it is pointing inwards. It will point inwards. If you keep your fingers in the direction of all the 4 fingers will be like this. All the 4 fingers will be like this. And thumb will be, they will then curl like this, and then your thumb will be in. So this becomes what? Minus k cap. Tesla. Inwards is here. You can write inwards also. You can write down this axis as well. Now for C point, see, direction will be the same because point is there only. First let me tell you for B part. See, if any point is lying on the axis of the conductor, no, be it here, be it here, be it here, anywhere in the axis of a conductor, at the axis magnetic field is 0. Not the central axis, on the line joining the conductor. At the axis, magnetic field is 0. You can even understand it by the logic that in Biot-Savart's law, what will happen? If your current element is here, point is also here, sine 0 degree becomes, and sine 0 is always 0. That's why. Then for point C, this will be mu naught I divided by 4 pi A, because this is semi-infinite. So it will be 4 pi into 10 to the power minus 7, 10 divided by 4 pi into 2. 4 pi gets cancelled, then this becomes 0.5 into 10 to the power minus 6, which you can write 5 into 10 to the power minus 7 minus k cap Tesla. I note down the solution. Did you understand outwards or inwards, Sahal? Is it inwards or outwards? First tell me. Did you get that? Inwards, outwards. So inwards is what? Axis. The axis that is into the page, that is your negative z axis. So we write minus k cap. The axis that is outwards, that we write as positive k cap. If the thumb was pointing towards the right, that is positive x axis, we would have used I cap. If the thumb was pointing towards the left, that is negative x-axis, we would have used minus I cap. Similarly, for upwards, if you get anywhere, then it is j cap. For downwards anywhere, it is minus j cap. So outwards is k cap, inwards is minus k cap. Clear, Sahal, now? And rest others also? Just text done when you've completed this writing part. Yes, your negative z-axis, so that's why it will be negative inwards. Or if it's possible, you can write it directly as outwards or inwards if you're getting confused with it. But when we'll do mixture of questions, no, where a segment of finite wire will be there, semicircle will be there, then your k caps and I cap, j cap will be in usage. All right, then try this question. Both of them are infinitely long wires. You have to find out the magnetic field at this point P. Try this. See, nobody has sent me any answer. Did people try this part? Let's see magnetic 1, B1 for this conductor firstly. This is P point. This part you people will be able to do. The formula for infinitely long wire was, what is the formula for infinitely long wire, Wafia?
B is equal to nu naught I by 2 pi a.
Perfect. It is B is equal to mu naught I divided by 2 pi A. So I think we don't need to even change anything. B is equal to mu naught I by 2 pi A. This much is given to us. A is the distance. Now direction. Sahal, can you tell me the direction? Inwards, outwards, or you can tell me minus k cap, minus plus k cap, j cap, I cap in terms of anything. Just tell me that.
For the first one, right?
Yes, for the first one. Just this is the point B, this is the direction of flow of current.
Inwards.
Inwards, perfect. Others also try. Keep your fingers in direction of current. Curl your fingers towards point B, thumb will go inwards. So because we are, taking calculations and additions, so we'll write minus k cap. This is B1. Now, formula for the second one will also be the same. Formula will be B is equal to mu naught I by 2A. But, Rifat, can you tell me the current in this second one? Just look at the figure. Can you tell me the current in this second wire? Rifat. Just tell me what's the current in this wire. Right, Samia? Rifat, are you there in the class? Yes or no? Yes, you're there. Now just see this wire. How much amount of current is flowing? Just see the number and tell me. 2I. Refer 2I. I was the current here, 2I is the current. So yes, others were right, Matiha, Sami and all. Here the current is mu naught 2 times the current 2 pi A. Fahad, can you tell me the direction for this second one? P point is here, this is the direction of flow of current. Fahad. Outwards, perfect. That is going out. So that becomes, let's write it in terms of K cap. Now your net magnetic field will be what? Net magnetic field will be simply the sum of both the magnetic fields. So B1 was mu naught I by 2 pi A minus K cap plus mu naught 2I divided by 2 pi A K cap Tesla. From here, if you wish, you can take things common also. What all common things you can take? Mu naught.
Ma'am, why did we take minus k cap for the first one, the first one?
Minus k cap because it was going inwards. So inwards is negative z axis. Are you agreeing with the fact that it is going
Yes, ma'am.
inwards?
Okay.
Yes. So for inwards it is negative z axis. That's why minus k cap. From here, if we wish to take common, we can take mu naught I by 2 pi A k cap common. Minus 1 plus 2 will be left from here. Minus 1 from here plus 2 from here it will be left. That makes it 1 ohm. So mu naught I divided by 2 pi A K cap test. Alright, note down the solution. Then we have this last topic for today, that is circular motion. Question, I think all of you must have written it, no, by now. Yes, I think by now you must have written it. Now, here comes the derivation part, and this derivation is important. Magnetic field at the center of, now there are three things that will come. First, we'll do at a center of circular coil. This means what? This means if this is a circle, that straight wire, no, that finite wire that has been curved and made into a form of circle. Fine. R is the radius of this circle. Now we are to derive, no, we are considering a very small portion of it. Very, very small, this much portion of it, which we are calling it as the current element. Remember current element I told you, very small portions from the circular or wire also we can take this. Now the derivation is very easy. There are three derivations, the derivation is very easy. Firstly, dl is this. Now, dB is equal to mu naught I dl cross R. See, current is flowing in this direction. So, current element, no, direction of current element, that will always be tangent to the radius. So, this makes an angle of 90 degree. So, when you'll open up this, no, dB, this becomes what? dB is equal to, why am I writing dB? Because I have taken a very small segment, dl. A very small segment, dl I have taken. This is mu naught I divided by 4 pi dl. This is vector form I have written. I can directly write it as sine 90 degrees divided by r square, and I have to integrate it. Then I'll get the magnetic field for the complete circle. Right now, I will, if I just calculate dB, I'll get the magnetic field for just a small portion dl. I have to find the magnetic field for the entire wire, for the entire circle. So now see, integration of the all the small magnetic field will give me the complete magnetic field. Mu naught I 4 pi r square. All these are constant. I am left with only integral of dl. Now think this, and all of you should reply me in the chat box. If all these small elements are dl, if I keep on integrating it, what will it be equal to? If I'll keep on adding all the dl, if I'll add all the dl, what will I get? All the small dl current elements, if I add, what will I get? Yes, right, Madhya, circumference. And what's the circumference of a circle?
2 pi r.
2 pi r, exactly. That is 2 pi r. So if you add all the dl, it means you are getting the length of the circle. And what's the length of the circle? Length of the circle is known as circumference. Yes, it will be 2 pi r only. So when you will integrate it for the whole complete wire, what do you get? D is equal to mu naught I divided by 4 pi r square into 2 pi r to integrate. So pi gets cancelled, 1 r square gets cancelled, and here 2 is left. See what's the final formula of magnetic field that you're getting. Final formula of magnetic field that you're getting is mu naught I divided by 2r. You have to remember this formula as well as you have to remember the derivation. If n is the number of turns, no, more than a single turn has been made, then magnetic field is equal to n times mu naught I divided by 2r. Regarding the direction is very easy. Direction of circular figures, no, it's easier than those length elements. You just have to curl your fingers where the current is moving. For example, if this is a circle, current is moving like this. Curl your fingers like this and in clockwise direction. Thumb is leading where? If you curl your fingers along the direction of current, thumb will lead into the page. So that's how you can see the direction. Direction I'll tell you later on. Direction, otherwise it will be confusing with the direction that you've studied. But apart from the direction, at least do the derivation. Write down the derivation, copy down the derivation. At any step of derivation, if you're not able to understand, ask. Direction I'll tell you at the end of this circle. we'll be using our right hand only. But just see the figures for semicircular, circular arc, all these things are there. First note it down. On next Tuesday, I will take your test, the upcoming Tuesday, when you have the class. I'll take your test only of the derivations from chapter 1, 2, and 3. Just the derivation part. No need to learn the formulas, no need to practice the numericals, just the derivation, because you people were making very much errors in the derivation part. So just a small test, I'll conduct it in the class only on Tuesday. So don't be scared of the test, it is just a subjective test on derivation. So you all know what are the derivations. Just like this, you have to write, consider a wire, R signifies radius and everything. Even many times in the class, I do not write it, but in the exam, you have to mention it.
Ma'am, is it necessary to write the vector part of the formula?
This, no, it's not necessary. It's not at all necessary. Directly, you can write this. dB is equal to mu naught. In fact, I also do not prefer this because it's of no use. Otherwise, ultimately, you get this only. IDL sine theta divided by 4 pi r square. Like this, right? Start from here, it's not necessary, not at all. But again, I was saying, you people have your investigatory projects, external examiner comes from Viva for your practical portion. So she can ask this to you. That's why I mention all these things. Otherwise, in the subjective paper writing portion, no need to write. Yes, Sahal, I didn't send it the link because you people were not added on the group though. That's why. So please, right now also, if it's possible, please share your number on the group. That has to be added. That's why I wasn't sending. Other students also from different batches wanted the recordings. So they have been added. Only you and Abia were left. Regarding the derivations, if you are just thinking about the derivations, how to do, I'll send you certain derivations. Those are important derivation. I'll send you those.
Ma'am, that n value will be given in the question, right?
N,
The last
n will be given to you. Yes, yes. If n is not given, it means number of turn is single. Single turn is there. N will be given. Sometimes 100 turns are given. N will be given.
I'm going to scroll up just a second. Here we don't have to write the DL sine 90 R square in the integration.
DL
Just DL.
sine 90, where?
Here after just DL, we just
This.
yeah.
Yes,
Okay,
yes,
so
you can
DL will
directly.
become 2. Okay,
DL
directly.
becomes 2 pi r, yes. Because integration of DL is actually, it's like you are adding all the small elements together. So ultimately it becomes what? It becomes a complete circle.
Got it.
Written.
Yeah, done, ma'am.
Others are, I think, also written. Now, from here, no, you will be able to remember all the steps, because next thing that we have is if it's a semicircular coil. If it's a semicircular coil, see, certain changes will be there. So obviously it's a screen for me, so I'll do it. But for you people, you have to write it again. That's a disadvantage for you. But do note it again. See, this will be the case. It will be a semicircle. Now, can anyone tell me what will be DL for it? What will be DL, integral of DL for a semicircle? DL is here, no?
Pi R.
It's pi r. Perfect. It's a semicircle. So now it becomes the circumference of a semicircle. So now what happens? It's mu naught I divided by 4 pi r square. Here you just have pi r. So pi r, pi, and this r gets cancelled. Formula of magnetic field for a semicircle is 4r. And even if number of n is the number of turns, so instead of 2r, it becomes 4r for a semicircle. This is 4r. Fine, so note down this. But again, I'm telling you, see, obviously it's a screen for me, so I'll be able to erase it and write it. And I don't want to carry the notes now with me, but you people should write everything again. Because when you'll revise it, do the derivation part, you should have it. So rest, this is just the thing that gets changed. All the steps are same, obviously. Far. See, if you start from the step, what happens? Where the change will occur? Till here, you will see it's sine 90 again. When you will come to the integration, then you will realize if you will add all the DL, it will be in the form of semicircle. And the circumference of a semicircle is pi r. So that's the difference. Rest of the steps are same. Others have also written. Shamya has done. What about others? Done? Okay, Rifat has also done. What about others? As you keep on doing it, no, when you're done, just text me done. All right, yeah. So those who have completed, you people can log out now. We'll meet in the next class, but do remember